All right. So this is our hardware connection, right? The diagram that we understand. Then these are the initializations, right? Include AVR/IO, include the header file for the time delay. Then we are defining these three. And you can use this directly, port C, DDR-C, and pin C. Now we understand the function of all these three registers. Right? Every port has three registers. So you can define them. Again, this is directly from textbook. Textbook say, okay, let us have this. And then initially you have a function for time delay. Right? Time delays, we have unsigned number passed, right? Integer D. And whatever value of D is, you will have millisecond time delay. Then you prepare 2 by 2 matrix. 4 by 4, thanks. Right? 4 by 4. So here we have 0, 1, 2, 3, right? And 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Right? This is still engineer's matrix. Right? A, B, C, D, E, F. These are hex numbers. So 4 by 4 matrix, right? Or array, whichever you want to use. And then we have row number and column number for every number. Right? So 0, 0, right? Row, 0, 1, 0, 2, and so forth. So for every element, we have row and column number. So that we want to detect. So this is our reference table. Then next step would be here it is. Right? Our main function, unsigned character, column location and row location. Right? And this is our keyboard routine. This sends the ASCII code for pressed key to port C. All right. So first is DDRD equals 0 cross FF. Okay. Why we want to do this? We want to send our number to port D. So port D is output port. Now we have DDR 0 cross F0. Okay. So again, key underscore DDR was our port C. Right? Port C, we have this configuration. First 4 bits are going to the rows that are output, and last 4 bits are input to the controller. So we have 0 cross F0. Fine. And we have PTR equals to 0 cross FF. So let us see. What was that? Our PTR was on port C. That is our output. So initially we say, okay, let us send only 1 to the output. Fine. So while 1, what we do, ground all rows at once. Right? Read the columns, check until all keys released. So this is just to check that all keys are released. If all keys are released, we read all ones to the input. Okay. And to do that, we can ground all rows together. This is just to check if the previous key is released, whichever key was. Right. So this is the loop for that. Then the loop is to make sure that if the key is pressed, right, keep checking for some time. So 20 millisecond delay. So these loops are still preparing us for making sure we come out of debounce, double key press, etc. Any question online? From here, our real detection starts. So we say, okay, we'll send logic 0 to any one of the rows, right? Check the columns. Right? If we find, we'll note down the row number and column number. That is it, right? We'll send logic 0 to one row at a time. We'll note down the columns. If we read any one column equals to 0, right, we'll note down that column number. We know the row number anyway. So we have row number and column number, and we have lookup table. So we find the number. All right. So to do that, We'll start with 0 cross EF. So EF means what? E would be 1110. That is E. Right? So in first 4 bits that are output from the controller, we ground one row. Right? 1110. That is E. Ground row number 0 and read the columns. Right? To read the column, we are interested in the last 4 bits. So you don't worry about the first 4 bits because we are sending that anyway. Same port. Right? So we end with 0 cross 0F. So last 4 bits are of our concern. So if it is not equal to 0F, that means what? Key is pressed. Right? What we read, if it is not equal to 0F, key is pressed. No key is pressed means all inputs are 1. So if that happens, we assign row location equals to 0. Right? Row location equals to 0. And we break out of this. Because we know our column number from this. We know our row number from this. We know, okay, row number is in this case 0. Right? From this, we can find out the column number. So we have the necessary data. Right? If what we read is 0 cross 0F, that means no key is pressed. With reference to that row, we go to the next one. And we send 0 cross DF. D is what? 1101. Right? 1101. So what we are doing is ground row number 1. And I can check if all of the columns read 1 or not. Right? If they read 1, go to the next. Otherwise, break. Right? And we now note down what is our row location, and we figure out what is the column location. All right. So these are 4 of them. Then BF. So B would be 1011. Right? That is the second row is grounded, and then we have 7F. 7 means 0, 1, 1, 1. All right. So one at a time, detect, note down the rows and columns. That is it. Once we have this detected, we can refer to our table. Right? So here it is. If column location is this, right, then what happens? Port D will get row location and 0. So this is E, that is 0th column. All right. Row location and the column. Right. So we have combination of this. If whatever you send, right, is 0 cross 0D, at that time, right, then we have whatever corresponding row location and the 1, and so forth. So this is referring to this table. This table. 2-dimensional table. And yeah, we detect the key. And then we start from the beginning. That okay, make sure to detect the next key, right? Everything is all the keys are released, and that is our initial condition. We send logic 0, 1 at a time, and we read. Okay, so this is the program. And of course, book has the detailed flow chart for this. But if you understand the program and the process, I think the flow chart is clear. Right, these are steps. First 3 steps to make sure that we are out of the previous loop, and step number 4, right, to make sure that we send one logic 0 at a time, detect the column, and interpret the key. So that is how we are using the keyboard question. 1 minute. This one, next. Okay, 1 minute. So let us see. You are telling that suppose we have collocation 0 cross 0 C. How you write down C? 1100. Now we don't want to do that. Right? So we don't have condition. Do we have any 0 cross 0 C? See, we are assigning column location in this program. Okay. So column location, right? We are detecting from this EF, DF, BF, and 7F. Right? So C will never be the case because we are not sending that. Right? So we have only 4 possibilities that we are sending out. Right? And make sure that we have only 1 0 going out at a time. Right? That is the condition. All right. So this is our key input, keyboard inputs, and this is how we detect. Any question at this stage? So we conclude our chapter 13 and move on to the next chapter. That is chapter 15 now. Right? Chapter 15. Any question at this stage? So now again, let us quickly see this with reference to embedded system. So we understand the displays, we understand the keyboard inputs. In addition to that, we need to understand a few of these things. Relays and opto-isolators. Okay. Stepper motors and DC motors. Let us see where we may need isolations, where we need relays. Okay. So first we'll begin with relay. Our controller generally operates at 5 volt. Logic 1 is 5 volt, logic 0 is 0 volt. Now you want to control real life appliances, we need some translation from on to our real life world. Right? So we need interface. And that can be done by relays and isolators. Where do you see, right? Relays, isolators, where we want to convert our signal of on from 5 volt to any other volt. 5 volt DC. It can be 12 volt DC, it can more than 12 volt DC, it can be AC, then we need to have different arrangement, of course. Right? Where do you see? Anywhere. We need to translate from one way of interpreting the signal to another way. Yes. Any example if you can think about? Amplifiers would be, yes, amplifiers would be there, right? Now amplifier would be in the analog world in a way, right? Here, so amplifier would be, we can have any analog signal. We make the signal louder. For example, this microphone is amplifier. Right? The input in this case is our analog signal. Of course, we have analog input as well. We study after Diwali, right? That can be one translation, right? From analog to analog, right? Put it this way. Right? This is one example where we need to translate the signal, of course, right? In this case, it is analog signal, my voice. This amplified version of my voice is translation in a way. Any other case, where do you think, right? Yes or no, right? This is our microphone system. Where else you want to say control something? Your TVs, your televisions run on how much voltage? Televisions, TVs. What is the input to your TVs? Right? Normally speaking, it is 230 volt AC. Right? We are controlling using your remote controller. what is the voltage range or output of the remote controller? Right. So that signal is there. Right. You see, remote control will work on how much, how many batteries you add to remote control. Right. Definitely not 230 volt AC. Right. It is working on DC voltage. So it sends the signal, right? Logic 1 or logic 0, whatever it is. It can be, say, pressing any key as well, on and off. Let us keep it simple. Right. You need some translation. So you are controlling 230 volt AC using DC device. Yes or no? Right. So there should be some receiver, and ultimately it turns on or off the 230 volt. Right. So there are many cases where we need these relays and opto isolators, and we study few of them. Now, first of all, BJTs and MOSFETs can be used as switches. And I believe you have studied BJTs in high school as well, and maybe in one or two earlier courses. So suppose this is our NPN device. You connect something here. This is your load. It can be a motor, for example. Now in this case, a DC motor, right? Or a bulb. You have VCC here, something that you want to turn on or off. We have BJT, and here is the ground. Now what happens if you apply logic 1 here? Logic 1 here, this is P, this is N. Right? So it is forward bias, it turns on the transistor. You have current flowing from VCC load transistor to the ground. So you are controlling the entire circuit by turning on and off this transistor. That you can do by sending, say, plus 5 volt here. Right? Plus 5 volt here. And this can be higher voltage as well. It can be 12 volt, for example. Right? So it behaves like switch. Right? Here is the symbolic diagram. This high side means towards the VCC, and here is the load, or it can be low side. Here is the switch, and the load is towards the VCC. So this can be one scenario. All right, transistor motor controls. You can explore more on Arduino website if you want. And this is just for your reference. BJT switch, it is what we discussed, right? The discrete BJTs, right? We have integrated circuit BJTs. They are very small. These are discrete BJTs. And here is another circuit. Right? We have BJT. We have any appliance that you want to turn on off. Right? This is ground, and here we can send, well, Arduino or our AVR controllers. Right? Arduino uses AVR controller in a way. So this is our circuit. And this is a generalized diagram from the textbook. We have AVR, that is logic 1 and 0 here, turn on and off of this transistor, turning on the circuit. And again, we can have many of these transistors. Right? In this case, it is, say, Darlington pair that amplifies current. So here are some diagrams of the ICs that amplifies current. This is a MOSFET as a switch. Here is a MOSFET. This is the circuit. Okay, don't worry about this diode. We have motor, we have a switch, and here is power supply. Right? In this loop, you turn on or off this MOSFET. You turn on or off this motor. And this is again from, so Arduino pin. It can be any of our AVR controller as well. So MOSFET, right, can be used as switch. BJT can be used as switch. Just another example, MOSFET as a switch. Yes, any question? In place of Arduino, we can have AVR controller, and by the way, Arduino uses AVR controller in most of the cases. So relays, if you talk about relays, it is an electronic control switch. Isolates two parts of circuit from each other, right? And small amount of current and voltage goes to switch a large amount of voltage and current. So here is the diagram, right? We can have a coil. If you flow current through it, it may attract this downward. So this can be closed and current can flow. So what is a relay? It is an electrically controlled switch used in industrial controls, right? Automobiles and appliances. And it has main three parts: coils, spring, and contacts. Right? So here are three combinations. So here is what may create a magnetic field, right? This can be attracted. It is normally open. So one connection is here, another is here. If it is closed, we have circuit that is completed. It is single pole, all right? We have only one of this and single throw. Single pole, double throw. We have both the sides. One of them is normally closed, another is normally open. You magnetize this, it will be attracted downward. Okay, this is closed, then this is open. And we can have two of them in parallel, double pole, double throw. So these are different combinations or types of relays. And yeah, these are part numbers and coil voltages, coil resistance, etc. Some description just from the textbook. Now here is one circuit that we can have microcontroller, we can amplify current, we have relay, and we have lamp. Right? Lamp is working on 12 volt. Here it is, this is the switch. Right? Now you can activate this switch based upon the current in this coil. Plus 5 volt here, you should send logic 0 here so that the circuit completes. Right? Magnetic field is there, it closes or opens this switch. So basically you are controlling this through the port pin. All right. So you should understand this diagram well. This is real life application of AVR. And if you want to note down, you can do that. And we have port pin. And this is just amplifier, current amplifier. And yeah, right voltage will turn on this circuit. Magnetic field will turn on or off the switch. And we have another circuit on the second side. You should understand this. Now, if you have electromechanical relays, we have few things. We have low life expectancy because of high wear and tear. So we go for solid state relays. They have high life expectancy and low wear and tear. So here is an example. Right? We have fan. Now we have AC voltage in picture. So here is our AVR. We can have, say, any port pin here. Plus 5 volt diode. You send logic 0. This emits light. This light can turn on any transistor, phototransistor. In this case, this can complete the circuit, and we can have the current flowing. Fan is on. Right? There is another mechanism, reed switch. Right? We have magnet here. It is a wheel, so it rotates. If magnet is in this position, it closes the circuit. Bulb is on. Lamp is on. The magnet is on the other side. You turn the wheel. Okay, this is open. The lamp is off. Right? So optoisolators that uses light. Now this is little bit theory. Don't worry. So we have two components: LED and phototransistors. So here is the scenario. Right? You can turn on the LED. That will turn on the phototransistor. Some specifications. This is the essential circuit. You should know this. Right? If you want to draw, you should draw it. This is the essential circuit. Everyone must know. Right? We control this LED. Right? In this case, plus 5 volt is here. You send logic 0 here. It will send lights. This phototransistor, it will turn on if we have light falling on it and completes 12 volt circuit. So we are controlling 12 volt lamp using AVR pin. So you must understand this circuit. If you want to draw, that is good. Right? Frequently I ask these type of questions, right, in the end sem exam as well. You need to understand this circuit. These are very simple circuits. This is how our embedded system relates to the real life. So you must understand. Don't worry about this additional pair of LED and phototransistor. You must understand this. Any question here? So this is opto isolator. It operates optically, right? And it isolates both the sides of circuits. Okay. You turn this on through current in this side. The light emitted from this diode will complete the circuit on this side. Right? So it isolates both the sides of circuit and is doing through the light. So optics is involved. So we call it opto isolator. And isolation is good because suppose there is some source circuit here. Now there is no electrical connection from this side to this side. Only light is there. Right? So any short circuit here will not damage anything on this side. They are isolated. Right? And anyway, we are not receiving light here. We are sending light from here. So any problem on this side of circuit will not impact this. Right? So generally this side is more expensive. We save our controller and the controller board and so forth. So we are isolating two things. Another thing is the voltage. Right? We have 12 volt here, for example. This is operated by 5 volt. So we can have higher voltage. Right? So it isolates two different say voltage levels. Right? So opto isolators must be understood by everyone. Right? You can have a higher voltage here. Now remember that you don't want to connect that higher voltage to any of the pins here, even accidentally, because your pin will have maximum voltage capacity. Right? And logic 1 is plus 5 volt for our case. Right? So is it clear for everyone? You should understand this thoroughly. And this is just an integrated circuit with two of these pairs. This is not connected. So if it is not connected, you don't worry. This is connected, so you understand this. So is it clear with everyone? Right? That how it is working. All right, few questions, right? AVRC program to perform following. Okay, so based upon this, let us have this question. Get input from a push button switch connected to port A.0. If the input is logic high, turn on lamp connected on port A pin number 1 by sending logic 1 on that pin and draw the circuit to implement about us. Use opto isolator to implement circuit. So how your circuit and program would be. Let us practice. And we have few minutes. What will be the drawing of the circuit? What will be the program? Very simple, but now we are translating it to the real world application. So everyone, we want to do both the things. Okay, simple circuits we need to understand. Right? So draw the circuit and simple program that will operate the circuit. So can we practice this? Everyone. Everyone online, you can draw it, and if you want to share with everyone, take photo and attach the file. Right? You can take the photo, attach the file. Program you can write on the chat box. So yes, everyone here, let us do both the things. And by the way, these are kind of questions that you may or may not see in the final exam. Okay. Do you have final exam papers in one folder? The previous year's papers are there or not? Not yet? Okay, let me upload them. But yeah, you never know, such questions can be there. So let us practice.